in this problem, we're asked to determine the voltage transfer function V0 of S over Vi of S as a function of S. There's our circuit, and to begin with, we'll do is we'll combine these two together to get an impedance. Then essentially we have a voltage divider. So for now, let's start with those two in parallel. So let's take, since they're in parallel, and let's add admittances in parallel to get an equivalent admittance. So we have 1 over R2 plus SC2, and if we get going over a common denominator, we have SC2 R2 plus 1 over R2. And what we're going to need is we're going to need an impedance. So I'm going to call or define impedance Z2, which is 1 over Y, and that's R2 over S C2 R2 plus 1. Now let's redraw our circuit, and there's our impedance Z2 of S that we just calculated, and we can find or write or express V0 in terms of VI using voltage division. So using voltage division, V0, it becomes Z2, which is R2 over S C2 R2 plus 1 divided by R2 over S C2 R2 plus 1 plus R1 plus 1 over SC1 times VI. Now it's just a matter of algebra at this point in time. We're going to have to work through the algebra to simplify and get it into a ratio of polynomials. So to start off, let's get these two terms over a common denominator. Also, I'm going to go ahead and divide through by VI. So we have V0 over VI, then is R2 over S C2 R2 plus 1 over R2 over S C2 R2 plus 1 plus S R1 C1 plus 1 over SC1. So now we've got a ratio of our voltages. Now, let's get everything in the denominator. Let's get everything in a common denominator. So our expression can be converted to this. And in the bottom here we'll have S C1 R2 plus S C1 R1 plus 1 times S C2 R2 plus 1 divided by S C2 R2 plus 1 times SC1. So now we've gotten the denominator, everything in the denominator over common denominator. And now if we note, we can cancel these two terms, and then we could rewrite this as SC1 R2, and we'll have SC1 R2 plus S squared R1 R2 C1 C2 plus S C2 R2 plus S C1 R1 plus 1. Okay, so again, just working on the algebra. Now, let's rewrite that, and let's group the terms in the denominator. So again, our numerator is SC1R2. And then our denominator we can write as S squared R1 R2 C1 C2 plus C1 R2 plus C2 R2 plus C1 R1 times S plus 1. Now, let's factor out the coefficient of this term here. Okay, so we still have SC1R2, but now our denominator will have R1, R2, C1, C2 times, so we'll have S squared, and then we'll have C1R2 plus C2R2 plus C1R1 over R1, R2, C1, C2 plus we'll have 1 over R1, R2, C1, C2. Now we can cancel out a couple of terms here. For instance, the R2 cancels out and the C1 cancels out. So our transfer function then is S divided by R1 C2 times S squared plus C1 R2 plus C2 R2 plus C1 R1 over R1 R2 C1 C2 S plus 1 over R1 R2 C1 C2.